I'd like to show you the differences that were incorporated in Wave for version 9.2. Uh, Primarily, it has to do with corneal scleral design. I'm going to load a file that I had already processed. This is a toric cornea, and I chose not to average in this case. A little over 4 diopters in cylinders. What I've done is, in the Tools menu, giving you a corneal scleral design option. And with this option, you can specify the corneal diameter. Let's say in this case it was 11.8. And you can choose a lens diameter. It goes up to 16.5, starting at 14.5. And you can specify an initial apical clearance, minimum being 200 and going way up to 800. So we'll start with this set of parameters. It's a four-step process. What Wave does is it creates basically a geometrically symmetrical design, and then it translates it into a free-form format so that we can independently adjust the periphery of the design. I tried to make sure that the lens is touching all the way around so that the bearing is not just distributed radially but circumferentially around the lens as it sits on the eye. With a 14.5 diameter lens, you have a fairly narrow bearing area in the periphery. And I've made some improvements so that if a design is brought into version 9.2, then the alignment area out here at the very edge of the lens is treated in a new way so that it doesn't get quite so curved. It's easier to control the angle and alignment when the periphery of the lens doesn't get so curved. Now, because we don't know what the angle is on this eye with the corneal data, we're starting off with a default of about 36, 37 degrees out here in the alignment area. I'll zoom in and you can see that that's close to the 37 degree line. The lens is the same all the way around. And you can see from the color map that it is basically a geometrically symmetrical design. The curves are the same on both sides for all intents and purposes until we get out to the very periphery. And that's why it's formatted as a freeform design. There are some tools that I've created. For instance, in this case, if we look at this design and we say, yes, we're close to 200 microns apical clearance. And I'll point out, since we specified the cornea to be 11.8, this is the limbus. So this would be the limbal clearance where we specified 11.8. We have 114, 120 microns clearance all the way around the lens. And that usually is going to work out pretty well. We could alter the apical clearance. Let's say that we used one of these new tools and decided to modify the central vault. Now, this doesn't work with every possible way of designing lens, but I wanted to let you know about that. We'll go ahead and proceed. Let's say we want to decrease the apical clearance by about 40 microns. So we would just click apply, and you can see those changes take effect on the screen. Now we have an apical clearance of about 160 rather than 200, 40 less. And we're still at about 37 out here, and our limbal clearance is still well over 100 microns. In many cases, we'd like to just change the alignment angle only in a certain area of the lens. Now this is a left lens, so if we were looking at this forcing pattern, the nose would be here. And quite often you'll find that in this area, the periphery of the eye is a little bit steeper. So let's say we wanted to try to address that. We could go to our tools and modify the alignment and increase the angle out there by, let's say about 60 microns. But we don't want to do it all around. We want to do it just in the inferior temporal half of the lens. So we'll apply that change and see that what happens, we have now about 39, 40 degrees out here, whereas up on the other side, we're still at 35, 36, like that. So we can adjust the angle just in a certain section of the lens. Now, whenever you make any adjustments, you ought to go back and check and say, yep, well, we're still at 160 for our apical clearance. And yes, we still have over 100 microns of limbal clearance. So these are the kind of tools that I think are handiest for us. There's another one where we can modify the limbal clearance. Let's say we are a little bit worried about having enough limbal clearance, so we'd like to increase it, and by about 20 microns all the way around. We would apply that change and observe what the effect was. You can see this lifted up a bit, and now we have a greater limbal clearance. It affected our apical clearance slightly, increased it a little bit. We could reduce that again if we'd like to, but our angles are preserved, and the lens is looking pretty good. So those are the kind of changes I've incorporated in version 9.2, some simple tools to design corneal scleral lenses. Again, you can go up to larger sizes too. You can certainly create a design for a larger cornea, let's say with a 12 millimeter cornea. In that case, we may want to use a 15.5 or maybe even a 16 millimeter lens. When we do that, we should use a greater apical clearance, I believe, and let the software give us a good starting point that we can refine based on what we see when the lens is on the eye. You can always change it to a geometrically symmetrical or a rotationally symmetrical design, but keep in mind when you do that, you're not really changing the geometry of the interior of the lens significantly, and you are impairing your ability to fine-tune the fit where it matters out there in the periphery of the design. Here's our 16 millimeter lens. Again, being very careful to touch all the way around. We're going to have a much broader alignment area with a design like this and still be clearing the limbus at 12 millimeters. I believe we asked for 300 microns apical clearance. And yeah, we get our 300 microns, and we've got a nice clearance at the limbus at 12 millimeters. And if we look at the edges, you can see, again, we're at about 37 all the way around. In this case, for a larger lens, it may be even more important to address any inferior temporal steepness. So once again, I'll use the tools to modify the design and change the alignment angle, increasing it fairly significantly, but only in the inferior temporal quadrant. I could click anywhere on here to change it, but this is the area that I'm interested in. And we'll see the effect on the screen. There's that steepening compared to the other side. Still at about 300 microns apical clearance, which we could adjust or change at any time. Still have a generous clearance at the limbus. So I hope this makes it easier for you to design your corneal scleral lenses and make adjustments as you see necessary once you get finished them.